Good afternoon. This is the 6 essential assignments and instructions for IPC, Integrated Physics and Chemistry Remote Learning 2020. I'm going to go and kind of go through each assignment for instructions. Attached is the periodic table for you to use to help you with these assignments. The first assignment is a periodic table worksheet, which is just becoming familiar with the periodic table and how to use it. With each of these, you have the assignment followed up by instructions and some notes to help you out here. These give you instructions such as this talks about 3 subatomic particles: protons, which are positive; neutrons, which are neutral; electrons, which have the negative charge. Tells you that atomic number is equal to the protons or electrons for a neutral element. The mass number is the protons plus the neutrons, and to find the number of neutrons, you take your mass number, subtract your atomic number, and you get your number of neutrons. Here's a couple of pictures. When reading the periodic table, the top number is going to be the atomic number. The one or two letter that you have here is the atomic symbol for that element, and most periodic tables will also have the name in the box as well. And then you have the atomic mass, and these can vary periodic table to periodic table. And then here's a Bohr diagram of an atom showing you the protons and neutrons in the nucleus and the electrons in the electron cloud. For this first assignment, you're just finding these elements on the periodic table, finding the atomic number, the atomic mass, protons, electrons. Then it's asking you to find and compare different traits of different atoms. Now you're looking at a Bohr diagram here that's labeled particles with no charge, neutrons, negative charge, electrons, and positive charge, and it's asking you to list out what they are and then figure out which element it is based off the protons. In the last section, you're given either the element name or the symbol. If you're given the name, you're asked for the symbol. If you're given the symbol, you're asked for the name. The second assignment is a valence electron worksheet. And valence electrons are the electrons in the outer shell that are responsible for bonding. You have 2 things to help you here. You have the valence electrons per group. The transition metals are blocked out here because those can vary for different ionic states, whereas these in the groups are set. You also have a periodic table attached to this worksheet as well to help you. So what you're doing here, and this is important for bonding and forming compounds, is you're given an element name, potassium, then you're going to find the symbol off the periodic table. The symbol for potassium is K, and then you're going to find where the potassium is in the periodic table. K is in the first column, so you can come up to the first column on here, and they have 1 valence electron. And that is how you find the valence electrons here. That's the second assignment. The third assignment is counting atoms. This is in compounds to figure out how many atoms you have. This also has an instruction sheet that follows. This is based off of, this is math, and it has a distribution, but the chemical formula has the symbol and count of each atom in the compound. Every time you see a capital letter, you have a new element. So for instance, NO3, you have a capital N and O, which means you have nitrogen and oxygen. Sodium phosphate, you have Na. The lowercase means it goes with the N for sodium. Then you have phosphorus and oxygen. Subscripts are smaller and they're written down to the right. That tells you how many of that one particular atom that you have that it follows. So for the example of N2O5, you have 2 nitrogen and 5 oxygen. Coefficients are out in front and they get distributed to everything in the compound. So in this example, 3Na2S means that the 3 is going to distribute to the 2 sodium, and it's also going to distribute to the sulfur. So that means you're going to have 6 sodium and 3 sulfur. Then if you have a polyatomic ion, which is denoted by a parentheses, the number outside of the coefficient outside the parentheses gets distributed to everything inside the parentheses. So on this assignment, you're just counting how many of each element are in the compound. So in the first one, you have 4H2. The number out in front, the coefficient gets distributed to the 2 here. So 4 times 2 gives you 8 hydrogen. Then in the second part, you're getting the total atoms in the reactants. So you're taking the 2 nitrogen, and then you have the 3 times the 2 for 6 hydrogen, so you have 8 total atoms, 2 nitrogen and 6 hydrogen. The fourth assignment is physical and chemical changes. There's instructions here and also describes a physical change versus a chemical change. In physical changes, you're just changing the physical appearance of the substance, or if you're mixing, the substances are staying the same. You still have the same substance. When ice melts, it is still the same substance. It's water, it just changed phase. But if you are to react something and you have new substances, that means that you have had a chemical change take place. They will not, a simplified way to think of it is they will not go back the way they were. And that's what you're doing for these 2 pages. If it can be changed, or you're just changing the appearance, changed back, it's physical. If you have a totally new substance, then you have chemical changes. The fifth assignment is balanced equations. And for this one, there's also an attached instruction sheet. And for this, you're seeing if the number and type of atoms on one side of the equation equals the types and number of atoms on the other side of the equation. Use the yield zero as a halfway point. So in this first example, if you drew a line straight down through the arrow on the left side, the reactants, you count your atoms just like in the counting atoms practice. You have 3 carbon, 8 hydrogen, then 5 times 2, 10 oxygen. On the product side, you have 3 carbon, you have 6 oxygen here, but you also have 4 here, so 6 plus 4 is 10. Then you have 8 hydrogen. So as you can see on both sides of the equation, you have the same number and types of atoms, meaning you have a balanced equation. If you have an example that if any one atom is not exactly the same, then you do not have a balanced equation. This is an example 2. And that's assignment 5. Assignment 6, conservation of mass, is based on the law of conservation of mass, which there is an instruction sheet that mass is neither created nor destroyed in normal chemical reactions. So the mass of your reactants, or on the left side of the arrow, has to equal the mass of all the products on the right side. So you're not losing any mass. And the best way to think of it is just think of it as a math problem where you have to have the left side equal the right side. So in these examples, example 1, you have 3 grams of hydrogen plus 18 grams of oxygen makes how many grams of water? Well, if you break it into a math problem, so you have 3 grams of hydrogen on the left side plus 18 grams of oxygen also on the left side, it creates how many grams of water? So you have the 3 grams plus the 18 grams gives you 21 grams of water is produced. So that's what you're doing in law of conservation of mass, is making sure that the total mass on one side of the equation on the reactant side equals the total mass of the products on the right side. And these are the 6 essential assignments and instructions for integrated physics and chemistry, IPC. Thank you.